Hi everybody. So I'm going to be talking about how to extend SBT API. I guess you've listened to people talk yesterday about SBT and how wonderful it is and how much everyone loves it. And I actually hope that by the end of this talk you might feel a little bit happier at kind of working with SBT and kind of doing custom modifications to your system. And hopefully you'll find it looks actually easy. Like my job will be done here if you're going, that was too easy, why did he even present it? Okay, so SBT, why native packager? So I generally think of Java is run anywhere, compile once, run anywhere. And native packager is run Java anywhere, because usually you've got things like the class path, the JVM parameters, command line parameters, environment variables. All these things aren't actually in the Java specification itself. They're things you have to inject from externally. And basically, SBT native packager gives you the ability to kind of create this wrapper that allows your system to actually run somewhere. So here's what you get with kind of the bash entry point. You get this kind of very useful kind of bash script that gives you the ability to add command line parameters, override the class path, set various things, and we want to use this. So this is kind of a good thing to leverage when you're trying to do something that you want to use in your runtime system. So if we want to use SBT native packager, we have to first of all really look at what the API looks like. So I'm just going to run through this quickly. That you have first of all settings. So settings are basically values which are computed once, and then after that, whenever you request the value, you get the same value again and again. So for example here, if you do set name equals, you define the value for name, the side effect print line here is run once when it figures out what the setting is, and then when you request the value of the setting, the code is never run again. In comparison, the task is a computation that's run every time the value of the task is requested. So here, for example, every time I define run to do a print line, and every time you call run, it executes the code. So usually you use settings to define kind of the configuration for your system, and then tasks are used to actually implement things. So we're like tasks, if you want to actually build an archive for your system, you're going to use a task to do that. And then the important extra bit on top of that is dependencies, that all tasks can depend on other tasks and on settings, and settings can depend on other settings. So if you want, the core thing that makes SBT actually easy to use is all you really have to do is find the setting or task that mostly does what you want, and just extend it, change it a little bit, just add a bit of configuration on top. So often there's not actually that much extra to do. And then the other bit that you need to be aware of is keys, which sort of connect the implementation of a setting or a task to an actual name that you can actually refer to. So as the native packager API itself, so it comes with a large set of auto plugins, and within these auto plugins are various tasks and settings that are used to that work together to end up creating an archive that you can actually execute. So when you go through this, you basically you go through the auto plugins and you find the plugin that has the kind of implementation that you need to depend on, and then you can depend on that and then use it in your own code. So universal plugin is sort of the basic configuration that's sort of used by everything else. The universal plugin allows you to specify a platform-independent layout. It lets you stage how this layout looks, so you can see where all the files go when you're creating your environment. It can also package zip and tar.gz files. And then all the other deployment formats depend on this. So you can actually use this to modify your environment in some way, and then that change can be used for all the deployment formats after that. And the most important bit in the universal configuration is the task called mappings. And mappings provides, it maps Java.io files to a path within a notional archive. And this will kind of define the layout of your system that can then, so where the files go and how they will be seen at runtime. So when you want to start building a plugin that uses SBT Native-Packager, first of all, you need to say SBT Plugin equals true, and you need to call add SBT Plugin that just pulls in SBT Native-Packager as a dependency. So now you have access to its API. And then you can create your plugin. You basically you create an auto plugin, and you do require Java app packaging. So Java app packaging is sort of the auto plugin that knows how to build the start script that starts your Java program. So if you require that, you pull in everything that's required to create a Java app, and you know that once your code and your settings here, once they're run, all the settings that you depend on have already been initialized. And then you kind of will define any custom settings depending on what you want to do inside object auto import. So this auto import section is an object that gets imported magically into your SBT files, so it's very easy for the user to reference them. And then the other things that generally you would do is you can create what's called a configuration that's sort of like a custom type of build, and you'd often create one of these if you wanted to say Debian is one kind of configuration, RPM, Docker. These all just create kind of an alternative configuration where you can customize certain things just for that. And when you use a config like that, then when you call project settings using this in-config with your config, scopes all your settings so that it's only used by the configuration that you specify here. Okay, so I'm actually going to try and go through some actual implementations and show you examples of how you might extend your system. So the first example here is the URKit profiler. How many people here have used URKit before? So nearly half. It's a really, really good profiler, and if you turn it on, it gives you huge amounts of information about what your threads are doing, where your memory is going, and sometimes it can be really, really useful. But it's actually a kind of a pain to set up. So usually, if you want to set this up, you go to URKit website, you try and find the right tarball to download it, extract it onto your system, then set some kind of environment variable or some kind of flag to say, hey, I downloaded it to here, and then hopefully maybe modify your start flags to say my Java agent is this shared object in this folder, and it's kind of a bit of a mess. So if we want to create a plugin that will actually integrate URKit for us, so what we want to do is include in our archive a platform-specific shared library, and we want to add the flags to enable this agent at startup, and then hopefully also be able to configure it so that it adds some configuration at runtime or at deployment time. So first of all, for adding resources, we want to basically dump a shared object into our image when we create it. So first of all, we can add resources, just put stuff into source main resources in our plugin, and then when we want to actually access that, we can call get resource as stream and write out a temporary file that we can then reference when we're building our image. Target here is usually you'll have target as an SBT setting that says here's sort of a temporary directory where you can dump all sorts of stuff. So that's usually get your target directory when you're doing SBT builds, and this allows you to refer to it. So then mappings, I referred to mappings earlier on as the way of accessing the path, the mapping from particular files to the location in your archive. So here I want to modify the mappings in universal. Remember, universal is that universal configuration that's used by everything else. So if we add a file here, it gets seen and used everywhere through the system. So we want to modify mappings in universal, and we basically somehow figure out we have this shared URKit agent that we've just written out here. This would be put into a task, and the result of running this will be the file that was just created. So then we can refer to that inside mappings in universal and add a tuple, which is that file that we just created, to the path that we want to put it in the file system. Okay, so now that we have the file in our universal mappings, we also want to somehow refer to this when the system starts up. So there is a way of modifying the way the Java app starts up. This is provided by that Java app packaging that creates the start script. We can inject arbitrary bash code, and some examples of what you might do with this is to add Java agents at startup, or maybe some kind of discovery, like maybe you're running on AWS and you want to discover what's your IP address, or what machine type you're on. So things like this could be done by the script. So for injecting arbitrary code, there is a setting that's bash script extra defines, and this is basically takes a sequence of strings, and this sequence of strings is arbitrary, basically just text that gets dumped into your start script, and this basically gives you a huge amount of control over anything you basically want to do. So you can do choose to do anything you want at runtime using this. So there's some helper functions in the bash script that are quite useful if you're trying to do various things. These ones, I think, are probably the most useful ones to look at. First of all, there is a setting app path, which is the path to the start script. And sometimes you've got things like maybe the agent, sometimes you may have to refer to a Java agent or something using an absolute path. So by using app path, you get access to the absolute path to some file in the archive you've just created. So say if you dump a file into a/b, you can refer to the absolute path by accessing app path /./a/b. Add Java adds an argument to the Java startup flags. So if you wanted to modify some setting with a -d, modify the memory usage, in this case adding a Java agent, then you would use add Java to add that. Add app then adds an argument to your application, so you can modify the arguments to your application as it starts up. And add residual is like add app, but it adds these arguments at the very end of the set of arguments passed to your program. So here's an example of injecting some bash code into our system. So you want to be as friendly as possible. So here I've added some examples where, so first of all, you might want to modify how your system works based on various environment variables passed to the system. So here I've decided, okay, I'm going to have a URKit agent disabled environment variable, and if that's set, then I'm not actually going to enable this plugin that I've just added. And so if -z, if this is set, then don't do anything. Otherwise, if URKit agent startup options is set, then we use that. Otherwise, we basically inject default startup options as the default set of default set of flags to be passed to the URKit agent when it starts up. So here at runtime, you can decide to enable or disable your app, and you can also change the parameters that you've configured from SBT. Then to actually add this into the script, you modify bash script extra defines, and you add Java and add an agent path. This requires an absolute path, so agent path $apphome ... add in our mapping, and here basically pass in some startup options that we can use as defaults. Note that generally I would use plus equals to append to the startup options rather than setting it to equal this, because if you want to use this you can use this trick for multiple plugins, but they'll only combine together if you append rather than replacing the value. But usually using this method, you can often combine multiple plugins using this kind of pattern. So if you want to try it out, you basically do add SBT plugin, blah, 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 and you call enable plugins. So say for example, you want to enable URKit on your place server. So enable plugins, place Scala, URKit, and this will basically modify your build so that URKit stuff is included. Okay, and when you're trying to figure all this stuff out and you're wondering why is it actually not working, and you want to iterate through working on your code and seeing how it looks and whether you're actually doing the right thing, generally you use the universal configuration again to figure out what's actually going wrong. So if you remember that the universal configuration is universal, and even if you're deploying using Docker or Debian or any other system, you can look at the universal definition first to see are the files in the right place, and you can also look at the generated startup script and see is it doing the right thing. So if you run universal call on stage, that will create a staging directory which contains the layout that you've currently implemented. So there's some online examples of this. So first of all, there is SBT URKit, which actually implements this, and it works pretty well. Then here's some other example plugins that follow a similar pattern because it's very easy to do. So here's SBT New Relic. So if you include the New Relic plugin, you get basically all the flags that enable New Relic monitoring for your app. It also has various settings that cause it to auto-generate a New Relic YAML file. So often if you're using New Relic, it's like you have to copy this YAML file from somewhere, modify some flags, and put it into your resources. But this does all that for you. Interestingly, you can also this uses Ivy to download an agent and then takes that agent and copies the jar file from it into the universal archive. So there's a lot you can do to modify these systems through this method. Another example then is Aspect JWeaver, which this one is very simple. It just adds the Aspect JWeaver as an agent. So it's just a lot easier than having to modify these flags manually. So these are the native packager supported formats. There's zip and TGZ archives. There's Windows MSI, DMG for OS X, Debian packages, RPMs, and it also supports Docker. So it supports a wide variety of target formats. So it would be interesting to see if we could maybe create a new format that, maybe there is a new format that that this doesn't support, or maybe say you want to deploy onto AWS Lambda, and you want to create an archive and use SBT native-packager as a base and then build on top of that. So this case, I decided that I would look at ACI images. So ACI is an image format that's used by Rocket. Who's heard of Rocket? Not many, but Rocket is basically a competitor system to Docker, that the people from CoreOS aren't completely happy with some of the technical decisions in Docker, and they're trying to build kind of a more principled Unix-style set of technologies that do more or less the same thing. So thought, why not try building this, and it might be useful. So it's basically it's a tar format, and then you can optionally compress that tar, and that you can also sign the images. And the format is very simple. First of all, there's a manifest file that's a JSON file in the root of this archive, and that contains the image metadata. And then there's also a rootfs directory, and the rootfs directory contains the like all the files that you want to be in your archive. So it sounds like pretty doable, pretty easy to create something like this. So first of all, we want to create some keys that are basically allowing the user to configure different aspects of the generation of this format. So here, basically there's this manifest file has a lot of different things you could configure. So not all the features are currently supported, but I've implemented specifying a list of dependencies. So dependencies are like other images that have to be downloaded, and then your image is merged on top. And this is obviously important for this kind of tool, because you probably want to depend on an image that contains Java, for example. So because you want Java in your image so it can run it. So then, besides having the keys that you've defined for your purposes, you would here it creates a config that's basically just like there was a Debian config and an RPM config and so on. We've got a new config that, especially for creating ACI images, that's created like this. Extend universal basically means it copies all the settings of the universal configuration, and then we now have these settings scoped in our custom config that lets us override and modify those settings. So then we need to create the file and path mappings for our new format. So mappings, so all of these are going to be scoped in this ACI config. So when we modify mappings here, we're going to be modifying mappings in the ACI configuration. So first of all, we will want to take all the mappings in universal. So the universal mappings are the kind of universal description of how to map a file to a path. But we're going to want to change this mapping so that all the files are put in the rootfs directory instead. So this is just basically rename all of the paths, so we include rootfs. I know there was some talk yesterday also about how to referencing settings and tasks, and whether the macros stuff is actually a good idea or not. I actually quite like using macros at this level, where here within a setting definition, I can, or a task definition, I can refer to the value of another task using .value, and this implicitly makes mappings universal a dependency of this. Sorry, it means that this mappings requires this value to be generated first. So this will trigger potentially whatever tasks and compilations and stuff are needed to actually figure this out. Besides renaming all the files in universal under rootfs, we also then have to add in our manifest file. So this ACI manifest is our task that generates the manifest file. And that task will, when you request the value, basically a task that, a good pattern here is a task that returns the file will basically generate that file and then return the file that represents the file that is just written. So then we need to basically write the implementation that creates the ACI image. So if we implement override package bin, which is the usual target for creating one of these images, like this is common across Debian packages, RPMs, and so on. So if we, there is inside the SBT API code, there is a call called make tarball that allows us to create a gzipped file using a particular set of files, which is from mappings here, and then we write it into this archive. And there's online code then here if anybody wants to take a look at how this works and how this extends the existing code. And the summary here is that extending SBT-native-packager is easy. It's quite good for altering the program environment, and it's good for if you want to create an alternative packaging format because you've got very custom requirements for how your code is executed. Questions? Yeah.
Right. Are there any plans to support not only packaging formats but also executable formats? So I had this issue a few months back that I wanted to have like a standalone file and it had to be a shell script, a native shared object, and a jar file. And it's kind of possible to cut these things together, but it's kind of painful to do it manually.
If you can write the code to do it, then it's possible. Like the mappings, the mapping from file to path is quite flexible. Like you have all the sources that are possible that give you the ability to run your program. So if you can basically then, I guess, SBT one jar or something like that, you basically want to munge them all together, and I think it would be possible. Like you basically want something like something that runs a shell script at the top that extracts the code and then runs it, right?
All right, yeah. Yeah, the complexity was basically that we needed some shared object, and it's kind of painful to do with system load or system load library. There are some restrictions in there which really require these things to be extracted first. And
okay, that kind of sounds like a packaging issue. Like if you were using Debian or something, you'd have a post install a script that would copy a file into the file system, or
yeah, we would try to do it with one executable. So basically, the issue, as far as I remember, was that it didn't work if we referred to the executed jar file as a native library. So we had like a shared object, renamed it. We had like in the beginning a shared object, in the end a jar file, renamed it to a shared object, and started it with java-jar, and couldn't get it to load as a shared object.
Okay. Well, you can move, by modifying mappings, you can move any file to some other location or rename it to any other name by changing the destination path. So that's one way of doing it. Basically, if it's possible to do within Bash, or it's possible to do by just altering the path on the file system, you can do it then. If you'd like to talk to me afterwards, I can see if I can help out with it. Any other questions?